Okay, now let's look at an integral where both bounds are infinity. So we're going to look at this graph, and if you looked at this graph in the calculator, it looks something like this. So we're going to try to find the area under this graph from negative infinity all the way to positive infinity. So remember we talked about when your bound is infinity, you can't actually plug that in, so we're going to have to rewrite it as a limit statement. But you're going to have to rewrite it as two separate integrals. And we need to split this graph somewhere. You can split it anywhere that you want, but I like to use 0. So I'm going to split this up into this, right? One of the properties that we learned is going from a lower bound to upper bound, you can split it up in the middle and add them together. So this would be the same as these two integrals. And then we're just going to do what we did previously, rewriting it with the limit statement. So limit as t goes to negative infinity. I'm going to use t here. And then limit as, I'll just use a different letter here, c goes to infinity. Okay, and then let's go ahead and take the antiderivative. The antiderivative 1 over 1 plus x squared is actually your arctangent. So this is going to be your arctangent of x. And same thing here, this is also your arctangent of x. And let's go ahead and plug in our bounds. So this is arctangent of 0 minus the arctangent of t. And then this piece here would be arctangent of c minus the arctangent of 0. Now, to evaluate the arctangent function, think about what the tangent graph looks like. So the tangent graph from negative pi halves to pi halves looks like this. So you're looking for here, what is the angle that gives you a tangent value of 0. This is exactly 0. Here, the arctangent of negative infinity. So think about your tangent graph. This is the tangent graph right here. This asymptote's at negative pi halves. So what angle are you approaching as this graph goes to negative infinity? You are approaching negative pi halves. And then this one here, as the tangent graph goes to positive infinity, as it goes up, it's approaching pi halves, and then arctangent of 0 is 0. So this is really pi halves plus pi halves, which is pi. So this integral converges to pi. Okay. Let's get one last one here. Let's try to figure out the area, if it's possible, of the function y equals e to the x, and e to the x is an exponential that looks something like this. We want to be above the x-axis and to the left of 1. So really, we're looking for this area here, if we can find the area. So your setup would be, okay, we're going from negative infinity to 1. The area of this function is the height of the rectangle times the width. Rewrite it as a limit statement. Antiderivative of e to the x is still e to the x. Let's plug in our bounds. So this is e to the first minus e to the t. And let's take our limit. The limit of e is still e. Oh, notice here, it is the limit of e to the negative infinity. So really what happens is when you have a negative exponent, it's going to drop to the bottom. So really you end up with 1 over e to the infinity. You end up with infinity on the bottom. So this limit goes to 0. So this area, or we say this integral, converges to